Alrighty, folks, here we go. We're going to do some Kahoot. All right, question one. The N and S on this bar magnet represent what? All right, so at that point, we're looking at here, and those are going to be the magnetic poles of our magnet. So, magnetic force is the actual push and pull of a magnet. And magnetic domains are what make up the magnet and need to be aligned in order for the magnet to be magnetic. Alrighty. Next up, what does it mean that there is no iron filings in the middle of the two magnets? So you see here, we are completely missing iron filings. And so what that means is that the area between the magnets has a very weak magnetic field because there is no metal attracted to that area. And that's going to tell us that we have two of the same poles facing each other, because when you have the two same poles of a magnet facing each other, they repel each other, and that magnetic force is pushing things away. So all three of these, the other three indicate that those would be opposite poles if these were true. So these are the same poles, so this one is true. Alrighty, next up. If you break a magnet in half, well, if you break a magnet in half, what you have is you have two new magnets. You have a magnet with a north pole and you have a magnet with a south pole. And that is true for both of these edges. So the magnetic domains still remain pointing in the same direction as before. And now you just have two new magnets. And every magnet has to have two poles. Alrighty. Next up, a compass is a small magnetic needle. What causes it to work? The compass is going to work because of the Earth's magnetic field. If the needle is magnetic, that means it responds to other magnets, and the Earth is a giant magnet, and so the magnet in a compass is going to respond to the Earth's magnetism. All right, next question. A compass needle moved when near a wire with a current running through it. This tells us what? Well, the compass needle is a magnet, and therefore that would mean that it is responding to a magnetic field. So an electric current creates a magnetic field. All batteries are not magnets. All wires are not magnets. They have to have current running through them, and electricity and magnetism are very closely related to each other. Alrighty, next up. Which of the following is magnetic? So we're looking at magnetic domains here. In order for it to be magnetic, the magnetic domains need to be mostly aligned, which would be B. When those magnetic domains are closely aligned to each other, then when they're aligned with each other, their magnetic fields align and they become stronger. Here, they're all mixed up, and so their magnetic fields are counteracting each other and therefore are becoming weaker. So magnetic would be B. All right, a ferromagnetic material is not what? Well, a ferromagnetic material is not always a magnet. It is able to be turned into a magnet, it is made out of metal, and it is filled with the magnetic domains, but those magnetic domains have to be aligned by a strong external magnetic field in order to be a magnet. And even once you do that, it will not always be a magnet because atoms are in constant motion, and that those magnetic domains will at some point become unaligned over time. So, ferromagnetic material is not always a magnet. Next up, in order for a charge to create a magnetic field, it needs to do what? Well, it needs to move. As long as the charge is in motion, it is creating a magnetic field. That's what happens when you plug in a wire like we did in that loop that I made with Orsted's demo. The charge was moving, it created a magnetic field. Doesn't matter the direction the charge is moving. If it was paired with an opposite charge, it really wouldn't have any effect, and staying still wouldn't really do anything either. So it just has to move. All right, how do you magnetize an iron needle? Alrighty, so if you paid attention to when we did the compass, in order to do this, it has to be exposed to a strong magnetic field, but it has to be exposed to both poles. So you rub both ends of a needle with opposite poles of a magnet, and that converts the two ends of the needle into opposite poles. It's not enough to just place it near a magnet for a long time. You have to do the rubbing both ends with poles, opposite poles of a magnet. All right, last question, folks. What does it mean when the lines of a magnetic field are closer together, such as at the poles of this magnet? All right, so we're looking at a picture here, and we see that the lines are closer together at the poles here and further apart in the middle. And what that means is that the magnetic force is strongest where the lines are close together, aka the poles. So that tells us, when the lines are farther apart, the magnetic force is weaker. There would have to be no lines for there to be no magnetic force, and those lines do not indicate anything about electric force. Alrighty, folks. So that is the Kahoot, and that is kind of the walk through it. If you have any questions, please let your teacher know.